multiplications and stuff like that.
Yeah. All right, so 1 through 40, any questions there? Yeah, if you have something, we can start with that. Then we'll dive in and run through this next set of topics. Yeah, Nat, go.
Can you do number 34?
Okay, so this was 11 cosine 5 pi over 6 plus I sine 5 pi over 6. Yep. Okay. So the directions here ask me to write this in standard form. So basically, I just need to do the multiplication and just bang this thing out. The thing that I'm noticing, though, is that 5 pi over 6 is a unit circle angle. So I should be able to look this up and get an exact value. I think the directions state to give an exact value if possible. So I definitely want to do that here. So let me think for a moment. Cosine 5 pi over 6, that's the 30 degrees over there. So the short side is the y side and long side is the x side. So that should be 3 pi over 2. And sine of 5 pi over 6 should be a half. Just grab the calculator and double check that real quick before we get going and I did it wrong. You know what I mean? Okay, good. It's always embarrassing, right? And then I just distribute the 11 through. And I'm done, so.
On the test, would you give us the units?
Yeah, probably, or the directions would not require an exact answer.
Okay.
But like, you know. Okay. Luke?
You do number 37.
Yeah, it's just the same set of directions here.
Yeah, but it's not like unit circle.
Yeah, that's okay. So 37 is 12 cosine 68 plus I sine 68. Yeah, so Luke's pointed out immediately that 68 degrees is not a unit circle angle, so there's no exact form expectation for this. So I'm just going to do 12 times cosine 68, making sure my calculator's in degree mode before I press enter there, which it is. So I got basically 4.5. And then we'll do 12 sine 68. And I got 11.13. Hi. Cool?
Yep.
Yeah. Right on. Everybody's like, this section, I'm loving it. It's like McDonald's or something. Ba-da-ba-ba-ba. I was expecting you to finish that, but all right, fine. Be that way. All right. It's too early. That's an invalid excuse. It's 9:30. I've been up for 5 hours already or something. Yeah. Yeah. I get up my alarm goes off at 4:45. Well, I live an hour away, and I have a 2-year-old daughter to get ready, and my wife needs to be work at 7, and I carpool with her.
Okay.
So.
What time do you go to bed
then? 9.
Okay, yeah. That's
Makes me pretty boring, but.
At 9 every night.
Well, we try to be in bed by 9. Some nights it's earlier. Depends on how quickly we can get the little one to go to sleep and how long we're willing to watch TV after she's sleeping. But usually, try to be in bed by 9. If you got to get up at 4:45, All right. The next section, then, we're going to be, in the first section, we talked about the complex plane and adding and subtracting and what I'll call scalar multiplication for complex numbers. Here we're going to just talk about multiplication and division. So let's talk about first multiplication in standard form. This should be a review from what we did last year in our Algebra 2 class. If I have something like 3 plus 2i times 5 minus 4i, what do I need to do to simplify this? Come on, guys. I know it's early. What do I got to do here? FOIL. Yeah, that's right. So I get 3 times 5 plus 3 times negative 4i, 5 times 2i, and then 2i times 4i. Everybody's okay there? What's I squared equal to again? Negative 1. So really that just becomes positive 8, right? Because I have negative 1 times negative 8. So if I combine like terms, then I get 23 minus 2i. NBD, right? One thing worth pointing out is that if I take two complex numbers that are conjugates of each other, remember, what does conjugate mean? Like the same parts with a different sign in the middle, right? Notice that this is just the same thing as a difference of two squares. So just like we had for our difference of two squares, I can apply that same fact or that same multiplication pattern here. Everybody's okay there? And that just lets me skip foiling. Obviously, you could foil this if you wanted to, but that's a shortcut that you could use. Only, though, when you're multiplying conjugates. Everybody's okay with this? Should come as a hugely review, right? We do this in Algebra 2, and we spend a bit of time here talking about complex number operations. So what if we then want to talk about multiplication in the trigonometric form? So let's say we have real number z1, that's r1 times cosine theta 1 plus I times sine theta 1. And we have some z2, so we'll call that r2 cosine theta 2 plus I sine theta 2. Oops, forgot that parenthesis. Okay, so we have these two complex numbers. If I multiply them together, it would look something, the multiplication problem would look something like this, right? Everybody feel cool there? Now these big brackets I put in there, do those really need to be in there? Nah, man. Okay, well, let's just not worry about that then. And since this is multiplication, can I do it in any order I want? Yeah, man. So I would suck the R1 and R2 out front. And then FOIL the remaining pieces. So I do that. I have cosine theta 1 times cosine theta 2 plus I cosine theta 1 times sine theta 2 plus I sine theta 1 cosine theta 2 plus I squared sine theta 1 times sine theta 2. So far, so good. I notice here that I squared, again, is -1. So if I group things together now that have i's and not i's together, have like cosine theta 1 times cosine theta 2 minus sine theta 1 times sine theta 2. I'll color code that. Then plus I times cosine theta 1 sine theta 2 plus sine theta 1 times cosine theta 2. And we'll color code these ones too. Is everybody okay so far? Here's the point of doing all of this. Does that look familiar? That's an identity. What? Yup. That is the sum of the cosine of the sum of two angles. Let's use a different color. I used the yellow up there already. Whoa, Mr. Kulik! Does this look familiar? It should, because it's a identity. Guess what it is? It's the sine of the sum of two angles. So this becomes our formula that we'll use to multiply complex numbers that are in the trigonometric form. Wait, what, Mr. Kulik? Hold on. Let me get this straight. So if I have z1 that's 4 times cosine of 172 plus I times sine of 172, and I have some other complex number z2 that's 7 times cosine of 13 plus I times sine 13. How can I do this? If I use the formula from above, I'm just going to do 4 times 7 cosine of 172 plus 13 plus I times sine 172 plus 13. So I get 28 times cosine of 185 plus I sine 185. Done. Mr. Kulik, that's like a mental math problem now. That's even easier than the standard form multiplication, isn't it? Yeah, man. It's pretty nice. Is everybody cool? Okay. So let's remember back to doing division in standard form. So I'll do a couple of examples here. So let's say I have the complex number 3 plus 2i divided by the complex number 4 minus 6i. I'm going to think about it instead as a fraction. I think that makes life a little bit easier. Do you remember how to divide these two things? Again, this was something we did last year in your Algebra 2 course. Well, you could do that, but it's not going to get the I out of the denominator, which is what we need to get a complex number answer, right? So, Anise, if we had this, then what you said would be fine, right? That it would work. Just multiplying the top and bottom by I would do it. But that 4 and then addition or subtraction is what's kind of ruining that idea. Can I give you a little hint? Yeah. So I made sure to do the conjugate multiplication up here for that very same reason. Notice when we multiplied the two conjugates together, you get a real number result instead of a complex number. That's the ticket here. So we need to multiply the top and bottom by the conjugate of the denominator. That'll get the I out of there, which is what we need. So the numerator, we got a FOIL. But in the denominator, that's kind of now just a mental math problem. We're using the difference of 2 squared, right? Is everybody okay with how I got to there? I skipped some steps, but there should be easy steps. Can you see it? You get where the plus sign's coming from? Because the minus and the I squared turn into a plus, right? Okay, so what do I end up here? We got, again, that becomes negative 12, so those cancel. So I'm just left with 26i over 40, which I could reduce down to 13i over 20. You guys feel okay with that? Does that ring some bells? Do we need to do another example, or you think you're good? Yeah, that's fine. No problem. So let's say 7 minus 2i divided by 3 minus I. So same setup. And what are we going to multiply the top and bottom by here? 3 plus I. Very good. So we'll FOIL the numerator. Just use my difference of 2 squares in the denominator. Again, remember I squared is -1, so it's 21 plus 2. And then 7i minus 6i is just I, all over 10. Nothing can reduce. So that's as good as we can do. And don't be thrown if we write it like this, right? That still means the same thing. Everybody agree? If people are being this, and this is probably the way they wrote it in the answer key, because we're clearly identifying the A and the B with the I as its own separate piece at the end.
Would either appear to be correct on the test?
Yeah, I wouldn't complain too much. I'm just letting you know if you look in the back of the book and you're like, wait, that's not what I got. And it's like, well, it probably is what you have. It's just like a different version of it. But if people are being real picky, the one that boxed in yellow is kind of the better way of writing it because it's like clearly in standard form. But like, I mean, I'm not going to worry about it. It's close enough. You know what I mean? All right. So what if we try to do this same thing in trigonometric form? Anybody with a prediction of what the formula is going to be? If I take, let's do the same thing we did before. So I have my same 2 complex numbers that we talked about earlier. Z1 divided by Z2. Anybody with a prediction? Remember what the multiplication formula looked like? It was R1 times R2 times cosine theta 1 plus theta 2, I sine theta 1 plus theta 2. For dividing, it's probably going to be R1 divided by R2. Hopefully nobody's surprised by that part. Cosine of, if we added the angles when we multiplied, what do you suppose we're doing when we're subtracting or when we're dividing? I just said it. I just spoiled my own question. So we're not going to derive that because basically it's the exact same derivation that we did before. You know? Bleh. You guys good with blehing it? If you wanted to try it on your own, you're welcome to do so. It's kind of neat. But you do the same thing we do for the standard form one. You just multiply by the top and bottom by the conjugate. The bottom reduces down to 1. And then the top part simplifies to cosine theta 1 minus theta 2, I sine theta 1 minus theta 2, doing essentially the same foiling exercise that we did before. Yeah. Not that interesting. Okay. So what does that mean then, Mr. Kulik? Well, say that we have two complex numbers. Z1 and Z2. Yeah. So if I want to divide the two, I'm going to have 14 divided by 2 times cosine of pi over 3 minus pi over 7 plus I times sine of pi over 3 minus pi over 7. And now, because this is in radians, it's a little less. There's one little hiccup here. What's the hiccup? You gotta make a common denominator to do the subtraction, right? Would that common denominator be 21? So what do we get? We get 7 times cosine of 7 pi minus 3 pi is 4 pi. Divided by 4 is just pi. Oh, that's not a 4 down there, Mr. Kulik. Your stupid, messy penmanship confused you. It should be 4 pi over 21. Nah, nah, nah. That's embarrassing that I couldn't tell the difference between a 21 and a 4. Yowza! And note here that once we've done this, if we actually wanted the answer in standard form, easy to do once we've gotten to here, right? So the point of the trigonometric form is that it's easy to do the multiplication and division, easier than when we were in standard form. So that's one of the reasons why we introduced the trigonometric form, is it makes these other operations easier. So if you had to deal with a lot of complex numbers all the time, multiplying and dividing them, I would make all my complex numbers into the trigonometric form, where it's just pretty trivial to do the calculation to multiply and divide them. You know what I mean? What do you guys think on this topic? Pretty easy, right? Well, that's it for that section. We'll stop here today because there's like a million homework problems for this section. So what do we got? We got 41 to 64. That's not even that many.
It took me like 25 minutes, not that bad.
Here's the bad part, though, is the next section has like 60 problems in it. So
Oh, wait, yeah, because it goes on.
yeah.
Is it easy at least?
No, it's the